Hello everyone and welcome back. My name is Mr. Kowalt, and in this video I'm going to be talking about density calculations. So I'm going to go over a few examples of how to calculate density. One of the things I want you to pay attention to is the fact that when you're doing density calculations, a lot of times you'll have a mixed amount of calculations. So you'll have to maybe do some subtraction to get to a mass or a volume, and then you need to divide to get to the actual density. So just to remind you, density is mass divided by volume. Simple enough, right? Just find the mass, find the volume, divide, get the answer, right? But when you're trying to figure out the number of sig figs to keep in your final answer, you have to pay attention to what you did to get the answer, right? And this isn't just for density calculations, but just calculations in general when you're trying to find the answer to like a measurement problem, right? So in calculating density, how did you find the mass? Was it given to you? How did you find the volume? Was it given to you? So in order to find mass or volume, you might have to subtract one mass from another or one volume from another to get the mass. But remember, the rule for uh, adding and subtracting is different when you're talking about rounding, that is. When you're talking about rounding your answer, the rule for adding and subtracting is different from the rule for multiplication and division. Remember, when you're adding and subtracting, the answer that you get from the addition or subtraction is should have the same number of uh, decimal places as the least number, or as the answer that has, as the measure that has the least number of decimal places. When you're multiplying and dividing, your answer should be rounded to the same number of significant figures as the measurement with the least number of significant figures. So when you're doing all of that together, you have to pay attention to what digits you're allowed to have after you do the calculation. I know this is a, a long version, a long-winded way of explaining this, but let me go over a couple of examples here, and then you'll see what I'm talking about. So let's talk about, for number one, uh, we're given the mass of a 2-liter graduated cylinder. So it's 1124.2 grams. We put in 1.20 liters of methanol. So we pour in methanol into the graduated cylinder until it gets to the volume of 1.20 liters. And then we get the mass of that together. So the mass of the graduated cylinder plus the mass of the methanol in the graduated cylinder is 2,073.9 grams. So they want to know, what is the density of the methanol in the graduated cylinder? Okay, so we need to find the mass and we need to find the volume. Well, if we find the mass and the volume, we could just divide. So what's the volume? Well, they gave us the volume, 1.20 liters. So that's the volume of our substance, so of the methanol. So volume is equal to 1.20 liters. Okay, we're going to convert that to milliliters because density is usually grams per milliliter. So if we take this, multiply it by a conversion factor, so liters is going to be on the bottom. 1 liter is equal to 1,000 milliliters. So liters cancel out, and then this becomes 1,200. So we have 1,200 milliliters of ethanol. So we got the volume. So now we just need to find the mass of the methanol. So we're going to have to do some subtraction, because when we added the methanol to the graduated cylinder, we know that the graduated cylinder itself is 1,124.2 grams, but the total of the graduated cylinder with the methanol in it is 2,073.9 grams. We just want the mass of the methanol. So we need to subtract out the mass of the graduated cylinder. So here, mass, that's going to be equal to the total here, 2,073 73.9 grams. And we're going to subtract out the 1124.2 grams. And when we do that, we get, give me a second, 949.7. 949.7 grams. Let me double check that. 949.7. 940, that's correct. So here's the number of grams. Now, so we have to remember our digits here. So volume, when I converted that to milliliters, that's multiplication. So remember, it's the number of sig figs. So my answer here should have the same number of sig figs as the least number of sig figs here. This is exact. This is 3. So this should have 3 sig figs. The only way I can represent this as 3 sig figs is to write it in scientific notation. So then this is going to be equal to 1.20 times 10 to the third milliliters. Now here I subtracted, and remember the rule here is that the answer that I get from subtracting or adding is should have the same number of decimal places as the measurement or inexact value with the least number of decimal places. So this has 1 decimal place, this has 1 decimal place. So my answer should have 1 decimal place. So it does have a 1 decimal place, so that's good. So now I'm ready to divide these two. So I take the grams divided by milliliters because it's mass divided by volume. So mass in grams divided by volume in milliliters. So 949.7 grams divided by 1.20 times 10 to the third milliliters. And when I divide that, I get 0.791. 0.791 grams per milliliter. And so you can see here that because I'm dividing, I got to follow the rule of multiplication division. So here, my answer should have the same number of significant figures as the least number of sig figs. This has 4 sig figs. This has 3. So my answer should only have 3 sig figs. So here is the density of the methanol in the proper number of sig figs. Okay, that's problem number 1. Problem number 2, here I have a bracelet and it has a mass of 50.901 grams. I put 18.2 milliliters of water into a graduated cylinder. Then I put the bracelet into the graduated cylinder, in the water in the graduated cylinder, and the volume rises to 23.0 milliliters. What is the density of the bracelet? So again, I have to figure out what the mass is and what the volume is. So, and I got to make sure that mass is in grams, volume is in milliliters. And that's what we have here. So in this case, I have to figure out what the mass is, or I don't need to figure out what the mass is because they gave it to me. So mass here is equal to 50.901 grams. And now I need to figure out what the volume is. Volume I need to calculate. Notice that, again, I have a graduated cylinder. I put a certain amount of water into the graduated cylinder. And then when I put the bracelet into the water rises up. The reason is because the bracelet, the volume of the bracelet displaces the water in the graduated cylinder, causing it to rise. So the difference in the levels of the water that's going to be the volume of the bracelet. So I need to subtract out the final volume. I got to subtract out from the final volume the original volume, the initial volume, 18.2 milliliters. So to find the volume, I'm going to take 23.0 milliliters and subtract out 18.2 milliliters. And when I do that, I get 4.8 milliliters. Okay, so now I have the volume of the bracelet. I have the mass of the bracelet. Now the volume, remember, because I subtracted, I have to follow the rule of subtraction and addition. Again, the answer I get should have the same number of decimal places as the least number of decimal places in my measurements that I subtracted. So this has one decimal place, this has one, so that way that one is the only decimal place, so that means my answer should have one decimal place, and it does. So 4.8 milliliters. So now I can go ahead and divide. So again, I'm going to divide mass by volume. So I have 50.901 grams divided by 4.8 milliliters. And when I do that, I get 11 grams per milliliter. Now, why is it 11 grams? Because when I multiply and divide, the rule that I need to follow is that my answer should have the same number of sig figs as the least number of sig figs in my measurements. This has 5 sig figs. This one has 2. 2 is the least. So my answer should have 2 sig figs. So 11 is the correct answer. So this is what I end up with. Okay, so I have 2 more problems, so stay tuned. Okay, here are 2 more problems. So problem number 3, very similar to problem number 1. You have a graduated cylinder again, and it has this time a mass of 48.737 grams. You add 13.2 milliliters of hexane this time to the graduated cylinder, and the total mass is 57.452. What is the density of the hexane? So again, we need to calculate the amount, the gram amount of the hexane. We're given the volume. So the volume of the hexane is equal to 13.2 milliliters. So all we need to do is follow or find the grams. So we're given that the total mass of the hexane and the graduated cylinder is this amount here. So we're going to have to subtract. So the mass of the hexane is going to be equal to 57.452 grams. That's the hexane with that's the graduated cylinder with the hexane. We need to subtract out the mass of the hexane. So we're going to subtract out the 48. I'm sorry. We need to subtract out the mass of the graduated cylinder so we can get the mass of the hexane. Sorry, misspoke there. So we're going to subtract out the mass of the graduated cylinder. So that's 48.737 grams. And then when I subtract that out, we get what? 8.715. So we get 8.715 grams. So that is the mass. Let me double check. 8.715. Yes. So this is the mass of the hexane that I put into the graduated cylinder. We have the volume of the hexane in the graduated cylinder. So now all we need to do is take the mass divided by volume. So we're going to take, one more thing. sig figs here. So when we add and subtract, remember that your answer should have the same number of decimal places as the least number of decimal places in the measurements you are subtracting. So here I have 3 decimal places. Here I have 3. So my answer should have 3 decimal places. I have 3 decimal places. Okay, so everything's good. So now we're going to take the mass. So we have 8.715 grams. We're going to divide that by the volume here. So 13.2 milliliters. And then when we divide those, we get 0.660. 0.660 grams per milliliter. And so this is the density of the hexane in the graduated cylinder. And again, I have 3 sig figs here because according to the rule, when I multiply or divide, my answer should have the same number of sig figs as the measurement with the least number of sig figs. I have 3 here. I have 4 here. 3 is less than 4. So I should have 3 sig figs. Okay. What about the next one? Here, I have a tree trunk that has a mass of 1.2 times 10 to the 4 kilograms and a volume of 2.4 times 10 to the 4 liters. What is the density in grams per milliliter? So here I don't need to calculate the mass. I don't need to calculate volume. So there's no subtraction or addition involved in this. So, but I do need to convert the kilograms to grams and liters to milliliters. So here, actually, you'll find that the ratio, if I was to divide these two, since they liters and milliliters differ by a factor of 1,000, and kilograms and grams differ by a factor of 1,000. Since they both differ by a factor of 1,000, that would cancel out, and you'd end up with the same density if I were to take these values and convert and divide them. But let's go ahead and convert them to the proper units anyway. So here, for the mass, I'm going to take the 1.2 times 10 to the 4th kilograms, and I'm going to use the 1 kilogram is equal to 1,000 grams. So 1 kilogram is on the bottom, and 1,000 grams on top. So kilograms cancel out, and then I end up with, this is going to be 1.2 times 10 to the 7 grams. And then I do the same thing with volume. So volume is equal to 2.4 times 10 to the 4th. And that's going to be liters. And that's over 1. And then I'm going to, again, convert this to milliliters. And I'm going to use the 1 liter is equal to 1,000 milliliters. So 1 liter is on the bottom. 1,000 milliliters on top. Liters cancel out. And so I get 2.4 times 10 to the 7 milliliters. So you can already see it's times 10 to the 7 times 10 to the 7. When I divide these, the times 10 to the 7 is just going to cancel out anyway. So let's go ahead and do this. So volume, density is mass over volume. So I'm going to take the 1.2 times 10 to the 7 grams divided by 2.4 times 10 to the 7 grams, or 7 milliliters, sorry. So these are going to cancel out. So the 10 to the 7 is going to cancel out. Oops. The grams are not going to cancel out, but 10 to the 7 will. And so it becomes 1.2 divided by 2.4. And that you could see is 1/2, 0.05. So 0.50 grams per milliliter. And so that is the answer. Now you'll notice that this has 2 sig figs in it. And that's because I have 2 sig figs here and I have 2 sig figs here. So this 0 is not significant. The first 0 is not significant, but the second 0 is. So 50. So 0.50 grams per milliliter is the density of the wood in the tree trunk. And so that, ladies and gentlemen, is how you do density calculations. I hope this was helpful. If you, excuse me, I hope this was helpful. If you enjoyed this video, if you learned a lot from this video, then please by all means like the video, share the video, hit that like button somewhere around here somewhere. Also, make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have any questions, if you have a question or a problem you want me to cover, put that down below. If you have a topic you want me to go over, put that down below. I would love to do that for you. Thanks for joining me and have a great day.